Okay, so we're going to go over limits and their properties, mostly graphically here, and some other things along those lines. So limits. Anytime you see a limit, it's actually an approximation. Sometimes the approximation gives you the exact value, but limits, we need to think about, what is it approximately? What is it approaching? That's really what it is. So as you're looking at this graph right here, a bunch of holes. I see a hole right there, a hole right here, right there, here, and a bunch of points that are just making, it's not continuous, it's a graph, isn't it? But lots of jump discontinuity here. So using this graph, and when we start talking about limits, that little minus sign and the exponent, that just means to the left. If it was a plus sign, it means to the right. If it doesn't have a plus sign, then or a minus sign, it means it wants it from the right and the left, and they have to match up. If the right and the left don't match up, it does not exist. Did I say anything brand new to you? This is a review to you. Okay, good. So let's do the first one. Let's look at -2 from the left. Everything you missed, Neelish, you missed a whole solid minute 30. You'll have to catch on the video notes. Are you going to actually watch them? Probably not. Okay, good. I like the honesty. Well, I better mark you present. Why are you late, Neelish?
Yeah, there's a traffic meeting from the school.
At 9:01, you notice there's a traffic jam in front of the school?
Yeah.
Okay. You're still late. Okay, so let's look at -2 here from the left. So that's this part right here. So what's the approximate value of -2 coming from the left side? Someone said 0. It is 0. From the left-hand side, we are looking at the path to the left. It's approximately 0. So it's going to be 0. What from the right-hand side? It's this path right here. And this is going to be approximately what? -1. Now, since there's nothing right there for a plus or a minus, we have to make sure that the left and the right match. If they don't match, it does not exist. So does the right and the left match for -2? No, so the answer is DNE. And then every single time we write does not exist, we need to state why. So why does it not exist? Not because of discontinuity, because it could exist. We'll find some of those. It's very, very simple. Because the limit as x approaches -2 to the left does not equal the limit as x approaches -2 from the right. It's as simple as that. A lot of times in the AP they like to say justify or explain. That's it. That's all you need to do. And then part D. F of -2. Now I want the exact value. What's the exact value at -2? It's -1. It's the dot right. It's the filled-in dot right there. Okay, looks like we're going to do the same exact idea here for 1. We're going to go from the left to the right. Do they match? And then the actual value itself. So looking at E here, as we approach 1 from the left, it's this path right here. What is that approximately? -1. From the right side, it's this path right here. That answer is 2. Do they match? So it does not exist. You have to state why. Oh, forgot my f of x up here. And then what is f of 1? What's the actual value at 1? This dot down here, which is -1. And now let's talk about 3. You should be. Alright, looking at 3, the path from the left is right here. What does that give me? -2. This is the path to the right, coming from the right. It's approaching what number again? -2. So what's the limit as x approaches 3? It's -2. You don't need to write anything y. As long as the right and the left match, then it's going to work out. So if I take my 2 fingers and I approach it from each side and they touch, you're good to go. But what's the actual value at 3? 1. Any questions on the first section? Alright, next one. What's up?
So like, when there's like a hole in just a regular one, what if there's just 2 points that are on the screen?
2 points.
Yeah, instead of one being a hole and one being a line.
So you're saying like if this was like this right here,
Yeah.
that's no longer a function.
Oh.
So we can't do it. It'd be a relation. So they won't ask you that. We only work with function, kind of, sort of. For these limit stuff, we only work with functions. Okay, so use the graph to answer the following questions. So why don't you go ahead and see how you do here. Answer these 6. Just give it your best shot, and then we'll come together. I'll be another minute, and I'll tag in. Alright, looks like we either did it and we're confident, or you're just staring like, huh? So, time to come back together here. Let's go with Jonah. What'd you get for the first one? As x approaches -2 to the left. -2. Any questions on that? Come from this side, it's -2. Max, what'd you get for -2 to the right? -1. Very good. It's coming from this side, so it's right there. Emily, what'd you get for the limit as x approaches 8? There's 2 Emilys? Oh boy. I don't know. The one that just said which one. You're up. It's 2. So the path here and here, they match up right there at 2. The other Emily now. What is f of 8? Let's just say 4. 3.5 isn't it? Yeah. Don't worry, if that was multiple choice, they wouldn't have 3.5 and 4 as options. They would clearly have 1. Okay, this was a little bit trickier now. So, as x approaches infinity, this is end behavior now. So, what's the end behavior as it approaches infinity? This one's a little bit tougher. It's gonna keep very slowly increasing. There's no asymptotes. It doesn't show me anything like any asymptotes or anything. So this is going to be as it approaches infinity. It's going to be infinity. It's very slowly increasing. Now, if there was an asymptote here, and then it would be signaling, oh, no, it's actually not going to cross this. But there's no asymptote. About negative infinity here. This one's open to anybody. -2. It's just a constant line. What's that? Because it's a straight line right here, and it's not going up or down. It's just staying. All right. Let's look at some of these limit laws. I don't know how familiar you are with this. So, the limit of a constant. Do you agree that no matter what number you put in for the limit at a constant, it's always that constant value? So, like the graph of y equals 2. Imagine y equals 2. No matter what the limit is on the line of y equals 2, it's always 2, right? So that's what that law says. Okay? And then the limit of x. It's actually a direct plug-in right there, because x is linear, there's no holes, nothing weird going on, so the approximation is an exact answer. So the limit as x approaches a of x is just a. And then we get to some stuff that's not too complicated here. I don't know why this cut off, but if you add two limits, this should actually say g of x right here. It just kind of got cut off when it got printed. So if you add two limits, it's the same thing as separating them from the inside and outside. Same thing with multiplying, and same thing with dividing. So if your limit is a function over a function, it's the same thing as the limit divided by the limit of the two functions. And here's kind of a weird one. Is this one right here, composition functions. So what you do is take the outer function, and it's just f of whatever that limit is. So it's kind of a little bit of a weird one, and we'll see these as we go through this next one. Okay, I'm going to go through the first 6, number 3, really, really fast, just because we've done a problem like this already. So the limit as x approaches 1 from the left. Let's go with Jason Lewis. What'd you get? What's the limit as x approaches 1 from the left? Yep. -3. Good job. Colton, what about 1 from the right? 1/2. Looks good to me. What about x as approaches 1, Neelish? What'd you get? So that's the exact value. Limits are approximation. That's like the 90 seconds you missed. Limits are approximation. So what you can do is approach from the right and the left. If your fingers don't match up, it is does not exist. Because the limit as x approaches 1 from the left is not equal. Yeah, get used to explaining things. So you take the AP exam. If you don't explain things, you lose lots of points. That's not good. Alright, Neil, since you already answered this one before, what's f of 1? -1. The exact value is -1. Annie, what about the limit as x approaches infinity? Negative infinity, because it's decreasing. So the end behavior is negative infinity. Rebecca, what about the limit as x approaches negative infinity? Give me infinity. Alright, so now for these next two, these are where they get a little complicated. So I'm going to want the limit as x approaches -2, and then I want to know what that is. And then I'm going to add 1, and then I'm going to divide by that. So this actually breaks up as this. So it's the limit as x approaches -2 of f of x, plus the limit as x approaches -2 of 1, all divided by the limit as x approaches -2 of x. It's actually all of that going on. That's part of the properties. So it's the limit of this plus the limit of that divided by the limit of that. So to find these three things, just put them together. So what's the limit as x approaches -2 of f of x? It's right here. What is that value? 0. So the first part is going to be 0 plus, what's the limit as x approaches -2 of just 1? It's 1, right? Is this on the graph, this part right here that I'm going over? Do you need to zoom in?
Yeah.
Is that better? Kind of. I had to squeeze that in there. Here, let me. All I'm doing is I'm just taking this problem right here and I'm writing it down here. So I do kind of need to squeeze this part in. So the limit x approaches -2 of x. Okay, so this first part right here, it's three parts of this problem. Limit as x approaches -2 of f of x is 0. The limit as x approaches -2 of 1 is it's 1. All over, what's the limit as x approaches -2 of x? What's the rule up here? Don't you just plug in the value since it's x? So it's -2. Which equals what? -1/2. Okay, so that's how the properties get used. So for this next one, this is the limit as x approaches 2 of f of x. That is not a typo, that is the question. So using the property, which is right here, composition of functions, this is the same thing as f of the limit as x approaches 2 of f of x. So what is the limit as x approaches 2? That right there, which is 0. What is f of 0? So this is an exact value now. So it's -4. Now, any questions on that? Alright. Next question. The next two questions are the same. I'm probably just going to go over just number 4. I'll skip 5. It's like the same idea here. It says to graph that piecewise function. Do you know that's called a piecewise function? It's got 2 pieces or 3 pieces. This one has 2. And then use the graph to answer the following. So we're going to just go over how to do this graphically, and then tomorrow we'll learn how to do this stuff algebraically, or maybe it's later in the notes today. I'm not too sure. So let's go ahead and graph this. How the heck do I graph a piecewise function? Do we just skip it? Let's just skip it. Take the hit. Well, which one's easier to graph of the piecewise function? The x squared plus 3 or the x minus 1? The x minus 1. So let's go ahead and graph x minus 1. That's a line with what y-intercept? -1. And what's the slope? It's 1. And I'm going to stop at what number? At x equals 2, right? That's going to be an open circle. Why is that an open circle? Because it's, yeah. And then you just... graph like that. So you're graphing left of 2, the x minus 1. It's an open circle because it does not equal it. Another strategy you could do is like plug in a 0, and you could plug in a 0 and plot that point. Plug in a 1, plot that point. Plug in a 2, plot that point. Plug in a 3, plot that point. They'll get you the same result. And just as long as you know the shape of it. So what is the value of 2 on the piecewise function? When I plug in a 2, I have to use the top one. What's that value? 2 squared plus 3, 7. What about 3? 3 squared plus 3 is 12, so it's like way up here. So you get the idea. Kind of looks like that. Okay, so now looking at this graph, what's the limit as we're approaching 2 from the right? Let's go with Isabel. 7, very good, because we're in this part right here. Now, what you could always do in these problems, you don't have to do this with graphing. You could also look at your piecewise function, and which one's 2 from the right? The bottom or the top? The top. And then you just plug in, and then boom, you get the answer. Okay? So 2 from the left. Let's go with Vassandra. What's 2 to the left? What do we get? 1. Very good, because we're looking at this path right here, so it is equal to 1. Again, you could have always plugged in the 2 into here, because that's the left path. So what's the limit as x approaches 2? Anybody? So it does not exist, because the limit as x approaches 2 from the left does not equal the limit as x approaches 2 from the right. And what's f of 2? Just 7. Alright, we get the idea? I have a feeling on the next graph they probably intersect. No, they don't. The next, number 5, is like the exact same thing. Do you want to go over that? I didn't think so. Okay, so these are 3 different ways that a limit fails to exist. So the first way kind of looks like a sine graph that, well, I won't make that an inappropriate joke. It's a sine graph that gets really tight in there. So it's oscillating. So you can't tell exactly what the limit is because it keeps going up and down, up and down, up and down. So this does not exist. Here's another one. If there's a vertical asymptote and one's going to negative infinity, the other one's going to positive infinity. Or there's this one where it's a jump discontinuity, so it jumps. So those are just 3 ways limits fail to exist. Again, it's easiest if you just always write this right here. Just always write that, and you're good. You're covered no matter what. All right, let's talk about continuity. So we're talking about if something's continuous or not. So continuity definition: to say that a function is continuous at x equals c means that there is no interruption in the graph of c. That is, the graph is unbroken at c, and there are no holes, vertical asymptotes, or jumps. Okay? So here are the ways that we cannot be continuous here. So here's a removable discontinuity. If you notice, we just have a hole right there. The limit on each side is equal, but it's not continuous because the function actually got removed and got placed right there. So that's one example. Number 2 is if there's an asymptote. I'm trying to draw it in because it's not drawn in, but it's supposed to be there. So it can't be continuous because in this case it can't equal 0. And it has the function described, by the way, right below it. And number 3 is that jump discontinuity I was talking about. This is where the functions actually jump. The left and the right do not match. Okay, so let's go through and let's discuss the continuity. So if the function is discontinuous, we got to say why. Otherwise, we'll just say that it's continuous. So number 6. Is that continuous all the way through? Yes. Because what shape is that, by the way? It's a parabola. A parabola is continuous. This is continuous. Number 7. Is that continuous? No. Where is it? Where is it not continuous at? So it's not continuous at x equals 2. Why? What's the reason? Because of the vertical asymptote. Right, because the bottom says that the bottom's never equals 0. In this case, if it equals 2, it equals 0, which results in an asymptote. Number 8. What we're going to do here to figure out if it's continuous is we're going to plug in these numbers. We've got to plug in the number from the path from the left and the right. If they match, then we're good to go. Well, kind of. The path from the right needs to match the path to the left, which needs to match the exact value as well. So if I plug in a 2 in the top one, what do I get? 1. If I plug in a 2 in the bottom, what do I get? Root 7. That's not continuous. What kind of discontinuity is that one? It's a jump, so it's not continuous at x equals 2 because jump. Discontinuity. Alright. What about this one right here? This is kind of a weird one. This one has a hole. How do I know it has a hole? Because this can factor as x minus 2, x plus 2. And those to cancel out. So we have y equals x. This is actually the graph of y equals x minus 2, but a hole at. So with a hole at -2, comma, -4. So in this case, the limits from the left and the right equal each other. That's great. But the actual value actually doesn't even exist because it's a hole. So this one is going to be not continuous at x equals -2 because of removable. I can't spell. Removable discontinuity. What about 10? Piecewise, so we're looking at either discontinuous or it's got a jump or removable discontinuity here. Plugging the 0 on the top, the path that goes from the top, what do I get? 1. What about the path on the bottom? What's e to the 0? It's 1. So they match. Now they could trick you. Is there a value for x equals 0 here? There is right here, right? So it does. They could totally trick you and just put greater than, and then the bottom one just be less than, and leave out the equal to, and then it would not be continuous. Those jerks, but they didn't do that here. So this is continuous. The right path and the left path match, and there is an actual value, which is the same thing. Alright, and then number 11. Well, does that bottom factor at all? Does it, or are you just saying yes? I'm assuming x minus 4 comes out of there. Does this work? 2x plus 7, x minus 4. Does that work? Yeah, so then those cancel out, so the function becomes 1 over 2x plus 7. So is this continuous? So it's not continuous at x equals what? 4. Whatever we cancel out, we set equal to 0. So it's not continuous at 4 because of what kind of discontinuity is this one? Got a hole, so it's removable. So here it is. So any questions so far? Yeah. So this one's also not continuous because of the vertical asymptote as well. So where's the vertical asymptote? X equals negative 7/2. So that one's got 2 of them. So the types of questions you'll have is, like on number 11, it'll be like a multiple choice question, and they'll ask where is it not continuous and why. And you have to say this. The choices could be there, or actually could be a free response, and they'll say where is it not continuous and why. It'll say for all values. So then you would have to mention all values, not just one value. Alright, so here's the technical definition of continuity. Anytime on a free response you're asked for, is it continuous, you need to state these 3 things. You need to state that f of c exists, whatever that number is, that the limit from each side are equal, and then therefore the limit is equal to that as well. Okay? It's a lot of writing. This needs to be memorized. So let's look at this graph. At 0, x equals 0. It says to justify our answer, that means we have to state everything. So for continuity, at x equals 0, what is f of 0? Look at the picture. It even says right there. F of 0 is 1. We want to do the limit. As x approaches 0 from the left, does this equal or not equal? Do the 2 paths equal each other? Okay, so this is true. Which equals what? 1. And the last thing I need to do is that limit as x approaches 0 of f of x is equal to f of 0, which is 1. So you need these 3 things to state that something's continuous. This is your justification. Not just, duh, look at it. Which people actually do put that on the AP exam. Just look at it. Okay, for B, x equals negative 2. Just look at it. Is that continuous? No. You do not need to state all of them. Which one do you want to state that fails? The second one. Because the first one doesn't fail, but the second one certainly does, and by default the third one does too. So, this is not continuous. And it's because the limit, x approaches negative 2 from the left. What is that from the left? It's 2. Does not equal the limit as x approaches negative 2 from the right, which is -1. And that's justification. Oh, and the first one, I forgot to say that actually was continuous. So this is continuous. Probably should answer it, not just justify it. Any questions? All done. Alright, so this is not graphing anymore. This is just doing this by hand. So, is this continuous? If it's not, let's find where it fails right away. So can you just look at this and figure out if it is continuous? How could you just do it just by looking at it? Do a little mental math, right? Plug in a 1 top and bottom. Do they match? Yeah, so this is continuous. The first thing, what is f of 1? That's in the bottom one. We're plugging it in, right? What is f of 1? What's 1 cubed minus 2? It's -1. What's the limit as x approaches -1 from the left? We said that this is equal, right? So you can go right to here. And it equals -1, correct? Sure, whatever. The teacher said it does. It must be true. So limit as x versus -1 of f(x) is equal to f of 1, which is -1. For number 14. Hey, look, they tell us what the answer is. They just say it to show it. So we know it's continuous. It said so let's go ahead and go for it. So we got to do our 3 things. So it says it's continuous at x equals 0. We have a trig function in there. Oh boy, and an e function. So we better remember how math works. Alright, let's go for it. So let's plug in a 0. So let's do f of 0. Is that the top one or the bottom one? Top one, because we got the equal sign. So what is sine of 0? It's not 1. Sine of 0 is 0. What's 2 times 0? What's 1 minus 0? It's 1. Yeah, we really need to know all those trig functions. What's sine of pi over 2? It's 1. Okay. What about sine of 3 pi over 2? -1. What about cosine of pi? -1. We need to know this stuff. We're not going to sit here and do a whole notes like on how to find these values. It's just assumed that you should already know how to do it. So if these values just crop up in an assessment, you better know them, because the whole point of pre-calculus is to have these things memorized. If you waste your time drawing a unit circle every single time, you're going to waste your time. So on the AP exam, each multiple choice question is supposed to take 2 minutes on average. Some take 1 minute, some take 3 minutes. On average, they each take 2 minutes. Okay? On each free response, which is usually 3 or 4, sometimes 5 parts, that takes 15 minutes on average. Again, some take 10, some take 20. On average, they're 15. So if you have a question that is like this, and you're sitting there drawing the unit circle, and you're taking an extra minute and a half, that's like a whole other question you don't get to. So you got to be sharp on this stuff. All right. So next one. So we're going to do 0 from the left, which equals the limit as x approaches 0 from the right, which is what value? if you're totally close, you could probably say what the value is still, right? It has to be 1, otherwise it wouldn't be continuous. So is that true? Well, plugged in a 0, we just did that, and e to the -4 times 0 is e to the 0, which is 1. And then you write down that third one. Gotta write this stuff down. Alright, last one. Oh, I love these questions. Find the constant a so that the function is continuous on the entire real line. So we have to take the path from the left and to the right and set them equal to each other. That's what we really have to do. So we have to do the limit as x approaches 3 from the left has to equal this, the limit as x approaches 3 from the right. Which one's the path to the left, the top or the bottom? Which way is the arrow? If it was like an arrow, it's pointing to the left, the top one. So this is 2. It's not x squared anymore because we're plugging in a 3. It's 2 times 3 squared minus 5 equals a times 3 plus 9. Oh. So why did I plug in the 3 again? Because you're supposed to plug in the 3. So that's what that step is. So now let's just do some algebra 1. What's 3 squared? Not all at once. What's 3 squared? Times 2. Minus 5. Good, I got you sound like a cult now. 3a plus 9. Subtract the 9 over and we're going to get 4 equals 3a. Divide by 3 and we get